Hello, I am Chan Jung from Dongguk University GTM Lab. The paper I will review today is six different approaches to defining and identifying promising technology through patent analysis. Here's the bibliographic information of the paper. The paper was registered in the journal Technology Analysis and Strategic Management in 2022. The keyword and research objective are as follows. The table of contents is composed like the table of contents in the paper. It's the introduction. The ability to respond to external environment is essential for companies to sustain growth. With the recent emergence of disruptive technologies causing rapid change in the technological environment, it is becoming increasingly difficult for companies to develop such capabilities. In response, companies have been making effort to establishing management strategies based on emerging technologies by identifying promising technologies. A patent database refers to multiple groups of patent or a single patent. In previous studies, some approaches clustered patent into multiple groups based on content similarity and then evaluated the promise of each group, while others used bibliographic coupling to detect outlier patent and then designated only those with high technological and market impact as promising technologies. However, the characteristic of patent considered as promising technologies can vary depending on the researcher, and also these studies did not explicitly use the term promising technologies. They can or be regarded to this concept. In this way, the diverse perspective on promising technology require different analysis designs, and the result may also vary. In patent analysis, numerous techniques have been proposed to identify promising technologies, and to address this issue, two approaches are possible. One is to define the characteristic of promising technologies, and the other is to thoroughly investigate the current usage of the term and then develop a classification system. Accordingly, the objective of this study is to develop a clear concept and classification system for promising technologies, and to present the definition of each type along with representative patent analysis approaches. There is no single definition for the term promising technologies, and most scholars have their own criteria for characterizing it. One study defined promising technologies as recently emerged technologies that have high uncertainty but also high potential for technological growth and market impact. In addition, the existing literature claims that promising technologies are addressed in at least four types: vacant technologies, converging technologies, emerging technologies, and customer-based technologies. To comprehensively understand these diverse perspectives, or classification system for promising technology is necessary. It's the research framework. A brief overview of the process of this study is as follows. In the first step, existing studies on promising technologies are collected from the scopes database to develop a draft of the types. In the second step, more paper or searches to supplement the initially developed topology of promising technologies, providing detailed explanation for each type. In the final step, the definitions of each type and the key patent analysis methods are presented, and a case study on autonomous vehicle is conducted to demonstrate how different definitions can lead to different results. First, in the data collection stage, paper related to patent analysis for identifying promising technologies are collected from Scopus. The research query is as follows, and a total of 514 record are retrieved, forming an initial database consisting of 8 fields: author, title, year, source, citation, count, abstract, author keyword, and index keywords. This is the definition and identification of promising technologies stage. In this study, attention is focused on author keywords analysis using two keywords, promising technology and technology forecasting. Also, keywords containing the term technology are identified and manually grouped according to definition similarity, including those with the same meaning, such as classified outlier patent as outlier technology. As shown in Table 1, the grouping of other keywords revealed that the most frequently appearing keyword was emerging technology, followed by converging technology, new technology, key technology, beacon technology, and outlier technology in descending order to frequency. In addition to examining each type in more detail, the term patent was added to the related keywords to limit the data collection scope to patent analysis. As a result, as shown in Table 2, a new database was constructed that addressed 6 types of promising technologies through patent analysis. At this study, 3 key paper for each type of promising technology are selected for in-depth analysis. First, in the category of emerging technologies, the study by Bengisu and Nigelli was the most cited. In this study, analyzed patent and publication data from ISI Web for 20 emerging technologies selected in Vision 2023, and also it did not provide a clear presentation of emerging technologies. It identified them through technology trend analysis. The most relevant paper is by Lee et al., which analyzed emerging technologies using patent and Twitter data. Cogens et al. State that emerging technologies refer to technologies that show high potential but whose value has not been proven or that have not reached any form of consensus. In the area of converging technologies, the study by Gabrielli was the most cited. This study reviewed previous research proposed various concepts and methodologies related to converging technologies and identifies converging technologies using patent based on relationship between IPCs. The most relevant study is by Kim and Kwang, which analyzed recent US patent trend to identify technologies that converge with information and communication technology. The study regards technology convergence as a synonym for converging technologies and defines it as a type of innovation that combines two or more existing technology to create hybrid technologies providing breakthrough function. In the category of new technologies, the study by Lee, Yun and Park was the most cited. The study developed a systematic approach to identify new technology opportunities. However, it was directly related to vacant technologies and was therefore excluded from feudal analysis. Quaco, Maribor, and Montalvio define new technologies as originating from a single idea within a selected set of homogeneous technological principles or resulting from the convergence of various ideas from different technologies built. In the category of key technologies, the study by Lee et al. Was the most cited, proposing an AMP-based approach to identify key technologies within a patent citation network. The most relevant study by Jun defines key technologies as technologies that are connected to most other technologies and exert influence of them. In the category of vacant technologies, the most cited study was by Jun Park and Zhang, which defines vacant technologies as technologies that will be needed in the future but have not yet been developed. The most relevant study clusters patent using their titles and abstract and designated certain clusters as vacant technologies, naming this approach vacant technology forecasting. In the category of outlier patents, the most cited study defines an outlier patent as a patent that is not strongly associated with the cluster to which it belongs. This study proposes an approach that conducts SAO semantic analysis on patent title and abstract clusters them into groups of similar patents and explores new technology opportunities through this process. As such, the key literature for each type of promising technologies is summarized in Table 3. For emerging technologies, converging technologies, new technologies, and vacant technologies, the unit of analysis was patent groups, whereas for outlier technologies, it was individual patents. In the case of key technologies, the unit of analysis could be either patent group or individual patent. Commonly adopted approaches include test mining, clustering analysis, and similarity analysis, while advanced analysis involve SAO semantic analysis, AMP, and density-based network analysis. In patent analysis, promising technologies can also be classified based on the unit of analysis and the time dimension. Key technologies and outlier technologies are generally identified at the individual patent level, whereas the other four types are analyzed at the patent cluster level. Emerging technologies and new technologies require patent analysis, while converging technologies and vacant technologies can be identified through stated analysis alone. In addition, new technologies are defined at the point when relevant patents first appear, whereas emerging technologies are defined at the point when relevant patents begin to increase. This is the comparative analysis stage. This stage, the aim is to explain the difference in analysis result according to the definition of promising technologies based on the methodologies used in the key papers. To achieve this, a four-step procedure is applied to patent related to autonomous vehicle. First, in the initial step, patent data are collected, including citation information, family patent, and species classification. Next, for each patent, a species list is created, and based on this list, a patent species matrix is constructed. Then, using the matrix, the similarity between patent is evaluated with the Jaccard similarity measure and the results were converted into a patent matrix as shown in figure 3. In this third step, the generated P2P matrix is visualized using KPI to construct a patent network. In this network, nodes represent patent and edges represent similarity. The network is simply built by applying the average value as a cutoff. After each modality algorithm is used to cluster closely connected patent labels or assigning to each cluster if necessary. Therefore, present the clustering and network result of the P2P matrix, which 2010 set as the best year, and the characteristic of 9 clusters are examined and labeled as shown in Table 5 and Figure 4. In the final step, which type of promising technologies were identified based on the network information. First, key patents are those ranked at the top in terms of citation frequency and family patent count. Among these, the patent with the highest citation frequency is US A3552112, and the patent with the largest number of family patents is US 9129088, both of which are identified as key patents. Outlier patents are defined as a patent without edges and isolated in the network. A total of 10 patents isolated in the network were identified as outlier patents. Beacon technologies refer to clusters with the smallest number of related patents. These were identified as 3 clusters with only 2 patents each: adaptive device, human detection, and attack defense device for 6. Converging technologies refer to a set of clusters with a large number of patents closely connected across clusters. The position, direction, and altitude control cluster contain 11 patents with 55% connectivity, forming a single network, while the non-electric control system cluster contains 18 patents with 94.7% connectivity. Both clusters share the species code G05D1, indicating the potential for technology convergence. Emerging technologies are defined as clusters in which the number of patents in P2 increases significantly compared to P1, while new technologies are defined as clusters newly formed in P2. In this analysis, a dynamic comparison is conducted between patents published in 2010 and those published in 2011. The following 6 clusters were observed in both 2010 and 2011, among them the transport, conveyor, and storage device cluster increased from 4 patents in 2010 to 20 patents in 2011, showing the largest growth and thus being identified as an emerging technology. In addition, 4 clusters newly appeared in 2011: pattern image analysis, radio navigation, propulsion by spatial interaction, and device used for it, and these are regarded as new technology for 2011. This is the conclusion stage. In conclusion, this study developed a classification system for promising technologies and present a new approach for identifying technologies from a patent database. It confirmed that the term promising technologies is used to refer to 6 distinct concepts: key patent, outlier patent, new technologies, emerging technologies, vacant technologies, and converging technologies, and through a case analysis of autonomous vehicle patent demonstrate that difference in conceptual definitions have a direct impact on result, thereby highlighting the importance of definition promising technology prior to analysis. However, several limitations exist. The data source is limited to Scopus paper detailing validation with additional database, and the study could not review all the latest approaches for each type of promising technologies. Thank you for your attention.